So hi guys, today we're going to learn a bit about neural networks. We are going to predict some digits, we're going to get some numbers, and we are going to predict if it's number 0, 1 till 9. So let's get into it. So you're going to understand this now when we start printing things and all that. We first are going to import all the things we need. I'm going to put it right here. We need NumPy as almost always, pandas, matplotlib. So that's all we need. From now, we are going to get our data that are all the digits that are over here, the digits.txt. These are all the images. These are all numbers of each pixel. So let's get into it. The data is going to be mp_load_txt, and this is going to be digits.txt with a delimiter of dot. Alright, so more of this. Later on, we are going to get the x, that is going to be the data that we have, all the examples, till -1. Alright, and the y is going to have the data with all the examples too, and it's going to only have the other one, and we're going to reshape it to make it as a column. Alright, we're just going to print both shapes just to know if everything is alright. Alright, we have 5,000 examples, 1, alright, and we have 400, like we have 5,000 images by 400 each image. What is that? These are images 20 by 20. Alright, so now we're going to first print some of the numbers just to show you. I just wrote this before, and well, it just goes by x, it just gets a random number between all these examples, and it's going to print 9 of them. So let's go, and well, these are the images, these are the numbers that we're going to train. Later on we're going to show another number, and let's see if it's going to work. Okay, so what are we going to do now? We also need to learn a bit about neural networks. We're not going to go very deep because we're going to use Sklearn as always. But here we have some images for you to understand. This is a neural network. We have the inputs that are the blue dots, the blue circles. Then we have the other layers. This is the input layer. The output layer is the last one. And the middle ones, we can have many of them or just one, and these are the inner layers. So we're going to have some inputs that in this case is going to be each pixel of the 20 by 20. We're going to have 4,000 examples, and with 4,000 pixels, sorry, and with these inputs we are going to do some operations in these inner layers in each of these neurons, and it's going to get us an output, and we're going to try to get an output between 0 and between 9 to get the number that we want. These operations basically, like we see, is A is just basically X, our inputs, and we're going to add to each of them our bias. Later on, we're going to go through all the inner layers. This is called the forward propagation, and it's going to do some operations like multiplying each input through a theta. That is a value that we're going to multiply to get our next output. We are going to use a sigmoid function, that is this function g that we use to set, that is going to get us the function to activate that neuron or don't activate it. And it's going to go through all the neurons. As we can see, they are all connected, and we're going to get this output. Just this is a general explanation. Moreover, we have here our cost. Our cost is going to be this. As I told you, we're going to use Sklearn, but just as you know, like we're going to use some logarithm for each function and multiplying that by the y that we want, and this is calculated because we are not going to go really through this, but just so you know. And later on, the most important part is the back propagation. This is how we really learn. Like in the training set, we are trying to predict, but for example, if we want a 1 and we got 0.8, we're going to have an error of 0.2. So we are going to have to adjust all these values that we are multiplying, these thetas, so we get a better value, and we get next time a 0.9 or 1, and we get that prediction 100% right. So as we can see, like the last one, the last layer, the output layer, is going to just as we did, 1 minus 0.8 is 0.2. So this is going to be like the error here. And later on, we're going to, through the other inner layers, we're going to go with all these functions, just transposing the matrix, multiplying, doing the scalar multiplication by other matrix that is going to also get the sigmoid function, and moreover. So first of all, we're going to predict, that is the forward propagation from the blue ones to the yellow ones, and later on we're going to do the back propagation through the output layer to the input layer, and to learn better those values to multiply it for future predictions. So now that we have everything more clear, we are going to start treating all the data. We only have the x and the y. We don't have a training set and a test set. So that's what we are going to do now. Sklearn has a library where we can do it all by itself. So we're going to get the x train, the x test, the y train, and the y test. This is equal to model selection, that is the library of Sklearn, dot train test split, and here we're going to put the data. We want to separate x, y, and we can put the train size or the test size. So we're going to just put train size over like a number from 0 to 1. So we're going to set this to 8. At training set by the 80% and 20% test size. I have forgotten to put to import this library here, so we're going to import it. Selection from Sklearn, import model selection, and we're going to use it to get this data. Later on, we are going to get we're going to just print the x train dot shape and the x test dot shape, y train dot shape, and y test dot shape, just to check. Let's see. All right. So we have these 400 pixels in each image, as here and as here, and here we have the training set that are 4,000 images, and here we also have 4,000 images, but here we have only 1,000 and 1,000. That is the x test and y test. All right, so we're good. So now what are we going to do? We're going to start learning and start training our model. So let's see how we do this. We're going to get our model. How we're going to get this model? We're going to use the MLPC classifier from neural network. We're just going to import it over here. If you don't have it, just make a pip install if you don't have Sklearn. So you import from Sklearn neural network the MLPC classifier. Alright, so MLP classifier. That is multiple layer classifier. Alright, so when we are here, we're going to create it. We have our model. We're going to call it neural network. It's going to be an ML classifier. Alright, and we are going to make well, we're not going to make any activation. We could have some parameters like the activation method that we want to use. Well, here we have some parameters we can set, but we're not going to use it. We could choose ReLU, or we can have maybe the max features, the maximum number of features that we are going to use, or we could also set the hidden layer sizes that we want. Alright, but we are just going to put it as the neural network is set. So let's begin. We're going to make the fit. Neural network dot fit x train y train. Alright. Like this, we are going to train it. Over here, we're going to make the prediction of train as always, and we are going to make neural network dot predict train x train ACC train is going to be the well, we're going to make it round, so round from metrics. We have the metrics, right? No, we don't have the metrics, so we're going to import it also here. We're going to do from Sklearn dot metrics import accuracy score. Okay, and we're going to, so we already have the metrics, and we are just going to do accuracy score from y train and the prediction train. Alright, so now that we have this, we all know that this prediction is not that good, so we are going also going to do the test prediction. We have it here, prediction of test. We are going to do now XY test, AC train test, accuracy score from Y test, and prediction test. This needs this and this. Alright, so we have it now. Alright, we're going to print both of them, both accuracies, ACC train and ACC test. Alright, that's it. We have an error. Accuracy score. Sorry, here we have a typing error. Accuracy score. Okay. It's just training and training. Here, yes, we have a warning. Like for, it says, let's please turn the shape of Y. It's just not really important, and we got 100% of accuracy. So we did everything alright in the training set. Later on, predicting and 94%. We could probably get this better by trying different values in the parameters, such as the activation, as I said before. Or we could also put over here where we will just put more inner layers here, or more neurons over here in the middle. Instead of 3 as here, we could put like 100 or 50 or 4 hidden layers with 5 hits. We could just try lots of things, but well, 94 is not that bad, so we are happy with that. let's see what we're going to do next. Okay, so finally what we're going to do, well, what I have just done is printing over here. Over here we have printed, I have drawn some numbers. Here's an example, sorry, this is example 5. This is an example 5 and I've done it with examples 0. I have drawn 20 by 20 0. Well, it's not 20 by 20 because in Paint it was a bit difficult and it's 23 by 22 or something like that. So this is a 0. This is a 1 that we have there. How you can see it there? Well, we can go like this. Okay, 1 and sorry, and finally we have number 5. Okay, so we're going to try to predict these ones. Sorry. Okay, now we're good. All right, so now we have this. We are going to get each image. We're going to get, all right, well, we're going to use plt matplotlib to read it. In read example 0.png, and over here, what are we going to do with the images? As they are 23 by 21, we are just going to get like this 20 by 20, and like PLT is going to read it as color images, like it's going to have the RGB values, and they are all going to be the same because it's black and white image, this one. So we are also going to get this, like 0, 1 and 2 are going to be the same, and we only need that dimension. So and later on we are also going to reshape it, because in the input image it's going to have 400, but only in a row, not 20 by 20. So here we just set 1 minus 1 and we get it a row. Alright, if we want, we are going to get the shape to see. Yeah, alright, we did it. Alright, we have 400 pixels there, 20 by 20, so we have all this image. Like in this 20 by 20, maybe we are not getting the last pixels of down below and on the right, but well, that's alright. We're just missing 2 pixels, 1 pixel. Okay, so now we have this, we are just going to use our neural network to predict. We're going to make the prediction of .predict, and we're going to predict our, well, we're going to set example 0. We're just going to get our images, both example 0, and we are going to get our both 2 examples more, like this and like this, example 1 and example 5. Example 1, example 5 is all the same, alright? And we are going to predict example the prediction, and later on we are going to get to put the number that we want, like this and like this. Predict 1, predict 5. Here we should get a 5, here we should get a 1, and we are going to predict both these 3 examples. So let's see how we do. Well, error, example 0 is not defined. Alright, yeah, sorry, X, yeah, X, boom. Alright, 100%. We did 100% well. We got a 0 in the prediction, we got a 1, and we got a 5. So as you can see, these images are not of really good quality. Let's see, like it's 20 by 20, so it's not really good, but for this training it did pretty good. And maybe it's not the perfect way to train with images, but as this is a really easy task for neural networks that are just numbers and 20 by 20, it's quite easy. Maybe we could get a better percentage in the test by using other things with the neural network, like to get more precision about how is that image and we could do it by different ways. There are some things that Sklearn also get us, like the Hawk algorithm. I don't know if you ever heard about it. That gets the things that are more important about each image. But we did pretty well with this, so maybe to train a neural network to learn what is a human and what is a tree and what is a lion, we should use the Hawk algorithm and more tasks, but with this is alright. So I hope you've learned a bit about neural networks and, well, digit prediction, and, well, I hope you've liked it. See you next time, boys.